Hi, welcome back. In this video, we're going to real quick review. Our line of reflection is our mirror line. If you have y equals a number, you're going to graph a horizontal line. If you have x equals a number, that's going to graph a vertical line of reflection. Then we looked at graphing across or reflecting across the line y equals x, our parent function of the linear equation. And all you have to do is take your x and y coordinates and flip your coordinates, your x and your y. So negative 5, 2 becomes 2, negative 5. In the next section, we're going to look at the negative parent function. So a common line of reflection is the parent function of a linear equation multiplied by negative 1. So this time I'm going to have a slope of negative 1. So instead of going up 1 over 1, we would be going down 1 over 1. And so I would end up with my negative parent function going this direction. My rule for reflection across the line y equals x is my original pre-image point xy is going to become, we're still going to switch them like we did before, but it's going to be the opposite of y, the opposite of x. Notice I didn't say negative y, negative x. It's super important not to think of this as negative y and negative x, because that leads to some really common mistakes of always wanting to put a negative number here and a negative number here, but that's not the case. When you read this, you want to read this as the opposite of y and the opposite of x. The opposite of y and the opposite of x. That's important because if you're looking at a number that over here in the pre-image already was negative, then when you come over here and do the opposite, it's going to become a positive value. Okay, so let's look at some examples. Reflect the triangles over the line y equals negative x. So the first thing I'm going to do, just like I did before, is I'm going to graph that negative x. And let me zoom in so that we can see a little bit better. Okay, so negative x, I'm going to, again, just like I did last time, I'm going to put all my little dots so that it's easier for me to, my eyes to kind of have a line of sight of where to draw that line. The more dots I have, the easier it is to draw the line. So here is my line of reflection. Okay, and then if I look at my points, this point here is the point negative 6, positive 6. And then this is the point negative 9, 3. And this is the point negative 5, 2. Okay, and so what my rule says I'm going to do is I'm going to switch the values. So my y is going to be in the front and my x is going to be in the back. And I'm also going to use the opposite signs, the opposite of y, the opposite of x. So my y value for my first point was 6. The opposite of 6 is negative 6. Then I look at my x value, which is negative 6. The opposite of negative 6 is positive 6. And I know that gave me the same answer, but that doesn't happen, and we'll talk about why that turned out to be the same here in just a moment. When I look at my next point, again, I'm going to do the same thing. I'm going to look at my y value, and that's going to move to the x position, but I want the opposite of y, so I'm going to have negative 3. And then I want the opposite of the negative 9, that's going to be a positive 9. Okay, then here the opposite of 2 is negative 2. And then here the opposite of negative 5 is a positive 5. So if I would have just looked at my formula and just said, okay, it says negative y, negative x, I might have come here and said, okay, I need to have negative, and then I would have maybe made these negative also, right? Thinking negative y, negative x, they should all be negatives. But it's really the opposite. So these negatives, when they move back here, they all become positive. These positives move to the front and all become negative. Okay? All right, so when I graph them, my new image points are negative 6, 6, and notice that's where it was, right? Because it's on the line of reflection, just like we talked about in the last video or 2 videos ago. If your point is on the line of reflection, it's like putting your finger on the mirror. its image is in the same point. Okay? Negative 9, 3 becomes negative 3, 9. Negative 3, 9 is way up here. And then negative 2, 5. Negative 2, 5. Okay, here is my triangle reflected across y equals negative x. So again, my rule is my pre-image xy reflects to the opposite of y, the opposite of x. Okay, let's do another example. All right, on the next one, again, I'm going to start off the same way. I'm going to sketch my line, and again, the more dots I have, the easier it is for me to draw that line. That's just for me, because I don't have a ruler handy. Okay, so here is my y equals negative x. Okay, now what's interesting is I see I have one point that's underneath the line and 2 points that are above the line. So when I reflect, the point that's below it is going to end up on the other side, and the 2 points that are above it are going to end up underneath it. Okay, so let's check and see how that works. So I have this point here, which is at negative 6, 3. And then I have this point here, which is at negative 5, 8. And I have this point here, which is at negative 2, 8. Okay, so when I am reflecting, it's the opposite of y, the opposite of x. So the opposite of y is going to become negative 3, and the opposite of x is going to become a positive 6. The opposite of y is negative 8. The opposite of x is positive 5. The opposite of y is negative 8. The opposite of x is a positive 2. Okay? All right, so now let's graph our new image points. I'm going to have negative 3, positive 6. I'm going to have negative 8, positive 5. And I'm going to have negative 8, positive 2. Here is my new image that has been reflected across this line. Now what's kind of neat, if I had a ruler and I did it really neat, is we would see that these lines where my pre-image, this one, and where my image intersect should be, if I drew it correctly, should be right on my line of reflection. Okay? All right, one last thing we're going to talk about real quick for this lesson is called reflectional symmetry. Reflectional symmetry is a type of symmetry where one half is the reflection of the other half. So you can fold an image and both halves match exactly. Okay, so the easiest place to see this is, for example, on a square, you could fold that in half. On a rhombus, you could fold that in half. You can fold a kite in half from the tip to tail diagonal. You could fold an isosceles triangle in half because it has the 2 congruent base angles. Okay, so anything you can fold exactly in half, and then that line of symmetry is going to be the line that divides it in half. Okay, so oftentimes, companies will use lines of symmetry to make their logos visually appealing. If we don't look at the words in the logos below, how many lines of reflectional symmetry does each one have? So where can I fold each one in half if we're not paying attention to the words? So we're not going to look at the word Mini, we're not going to look at the word Audi. Okay, so let's see where we could draw lines in these. Okay, when I look at the first one here, I can draw a line right here where I could fold that picture in half. And it would be exactly the same on both sides. Well, I can do that there, but I can also do it here. And I could also do it here. So this one has 3 lines of symmetry. Okay, 3 reflectional lines of symmetry. Okay, when I look at, we'll look at this one next here, the mini one. Now the mini one, if I don't look at the words, if I ignore this part where I've got the words, pretend that part's not there. Okay, and I'm looking at just the silhouette of the logo, I can see that if I draw a vertical line through it, the left side and the right side are going to be exactly the same. Now, if I try to do that horizontally, it's not going to be the same because these 2 corners, when they fold up, aren't going to match with the outside, right? So this one only has 1 line of symmetry. Okay. All right, then my VW logo over here, where can I divide that one in half? So this one, I can divide this one in half, also vertically, just like the mini logo. Okay, and it looks like that's going to be the only one that I can draw on that one. So this one only has 1 line of symmetry. And last but not least, my Audi logo. When I look at my Audi logo, I can fold it vertically, just like I did the other ones, right? If I put a line right here, because remember, we're not going to look at the words, we're just looking at the logo, because it tells me up here if you don't look at the words in the logo. So I have 1 here where I can fold in half. And let's see, are there any others? Well, you can fold these circles top to bottom. And you would have a 2nd line of symmetry. I don't think you could do diagonal, right? Because that's not going to line up if you try to do diagonal. So it's just going to be these 2. This one's going to have 2 lines of symmetry. Okay, and so that is reflectional symmetry. So today we looked at reflecting across y equals a number, reflecting across x equals a number, reflecting across the parent function of a linear equation y equals x, and reflecting across the parent function y equals x multiplied by -1. Okay? If you have any questions, please make sure that you are attending sync time and asking your teacher if you have any questions to follow up. All right? Thank you so much for watching.